Autophagy plays a quiet but essential role in maintaining the effectiveness of the immune system, particularly in its ongoing battle against cancer and the challenges posed by aging. Far beyond its traditional identity as a cellular recycling mechanism, autophagy supports the integrity, responsiveness, and survival of immune cells. It enables the immune system to function with precision, to recognize and eliminate threats, including tumors, and to adapt as the body grows older. When autophagy falters, as it inevitably does with age, immune surveillance weakens, allowing cancerous cells to evade detection and age-related decline to accelerate. In the context of immune surveillance, autophagy enhances both the innate and adaptive branches of the immune system. It supports the maturation and function of antigen-presenting cells, such as dendritic cells and macrophages, which are responsible for detecting abnormal proteins, including those produced by cancer cells, and displaying them for destruction. Autophagy also plays a critical role in maintaining T-cell viability and metabolic flexibility. These T-cells, particularly cytotoxic CD8+ subsets, are the immune system's front line against tumor cells. Their ability to proliferate, traffic to tumor sites, and exert sustained killing activity depends heavily on efficient autophagy. Without it, T-cells become energetically compromised and exhausted, less able to respond to emerging threats or chronic inflammation. With aging, autophagic capacity diminishes in most immune cells. Lysosomes become less functional, nutrient sensing becomes impaired, and oxidative stress overwhelms intracellular repair systems. As a result, older individuals experience a decline in immune vigilance, a phenomenon known as immunosenescence. Senescent immune cells are less capable of responding to new infections or eliminating early-stage cancer cells, leading to increased susceptibility to both pathogens and malignancies. Moreover, senescent cells often secrete pro-inflammatory cytokines that further disrupt tissue environments and promote tumor growth. The loss of autophagy thus contributes to a systemic collapse of immune regulation, fueling both cancer progression and age-related immune dysfunction. But this decline is not inevitable. One of the most encouraging insights from current research is that restoring or maintaining autophagy can rejuvenate immune function. In mouse models, genetic or pharmacologic enhancement of autophagy in T cells has been shown to improve anti-tumor responses and restore immune competence in aging animals. Caloric restriction, exercise, and intermittent fasting, all known to stimulate autophagy, have similarly been associated with better vaccine responses, improved pathogen clearance, and reduced cancer incidence in animal studies. These findings suggest that preserving autophagy may be one of the most effective ways to slow immunosenescence and extend healthy immune function into old age. The implications for cancer treatment are especially compelling. Many immunotherapies, such as checkpoint inhibitors, depend on the functional integrity of T cells and dendritic cells to generate durable responses. If autophagy is impaired, these therapies may fail, not because the drugs are ineffective, but because the immune machinery they rely on is too degraded to act. Supporting autophagy in immune cells could enhance the success of these therapies, turning partial responses into complete remissions. This is particularly relevant in older patients, whose immune systems are already compromised and in need of cellular repair as much as activation. However, this therapeutic promise comes with a critical warning. Autophagy is not exclusive to immune cells. It also functions in tumor cells, often helping them survive in nutrient-poor, hostile environments. Interventions that broadly stimulate autophagy could unintentionally support cancer cell survival, especially in advanced or treatment-resistant tumors. Conversely, inhibiting autophagy to weaken tumor cells may impair immune function at the same time, undermining the body's own defenses. This paradox highlights the danger of simplistic interventions. Effective therapies will need to selectively enhance autophagy in immune cells while suppressing or disrupting it in tumor cells, an immensely difficult task that may require cell-specific delivery systems or context-dependent activation. Nonetheless, the overall outlook is positive. Autophagy is emerging as a central regulator of immune integrity, a process that links metabolism, cellular stress, and the capacity to fight disease. By preserving autophagy in immune cells, we may delay the onset of immune aging, boost resistance to cancer, and improve responses to both vaccines and immunotherapies. The challenge is not just to extend lifespan, but to extend health span, to ensure that the body's surveillance systems remain sharp and resilient in the face of aging. In that light, autophagy should be viewed not only as a metabolic process, but as a critical pillar of immune health. Its decline may signal the beginning of immune failure, while its preservation offers a path to sustained defense against cancer and degeneration. By supporting autophagy, we may enhance the immune system's ability to protect us well into later life, turning back the clock not just on aging, but on the loss of biological vigilance that allows disease to take hold.